All right, so we are starting our next little section, 12-5, distance on the coordinate plane. We're going to begin on page 299 if you have your digits book, otherwise in a comp book or on a piece of paper. So here it says that they want us to try to find the perimeter of each of these triangles, and then they want you to know which one is the greatest. So in order to find the perimeter, we're going to need to use Pythagorean theorem. So this is a great way to review on solving for the hypotenuse. This leg length right here, we're going to start in quadrant 1, is 1. This leg length, we're just counting these units, 1, 2, 3, 4, 5. This is 5 units. So if I'm starting in quadrant 1, I'm doing 1 squared plus 5 squared, and we're doing equals c squared. We're doing 1 plus 25 equals c squared, or 26 equals c squared. And we take the square root of this, and the square root of 26 is about 5.1. So now that actually doesn't tell us the perimeter. The perimeter is 1 plus 5 plus this hypotenuse is now 5.1. So my perimeter here is going to be 5 plus 5 is 10, plus 1 is 11, 11.1 units. Okay, I'm going to switch colors. Do quadrant 2. Quadrant 2, we have a 1, 2, 3, 4 by 2. So quadrant 2, we have a 2 squared plus 4 squared equals c squared. Again, we're just practicing solving for the hypotenuse. These are all right triangles. So we have a 4 plus a 16, and we are getting c squared. We have a 20 equals c squared. If you take the square root of that, the square root of 20, and these are all approximate, is about 4.5. And then it's, again, remember we're trying to go for the greatest perimeter, and perimeter is the distance around. So now we add these together. So 2 plus 4 is 6, plus 4 is 10, and again, we have that 0.5. So this one here is 10.5. If you notice, we're going to skip down here to quadrant 4. This is also a 2 by 4, which is going to make this hypotenuse 4.5, which is going to make this perimeter 10.5. So without even doing any math, with just noticing that these two triangles are the same size, we know the perimeter is 10.5. Okay, quadrant 3. Now we just need to know the biggest. So is quadrant 3 bigger than 11.1, which is right now our biggest? So 3 by 3. And remember, we can't just add these together. This hypotenuse length is not 6. It's also not 3 just because it goes diagonal across 3. So let's go. We're going to do our Pythagorean theorem. 3 squared plus 3 squared equals c squared. And we hopefully have started to memorize some of these. This is 9 plus 9 equals c squared. So we have 18 equals c squared, and to get plain old c, we take the square root. And the square root of 18 is about 4.2. So if I go back up here and I write 4.2. Now, again, we're repeating. We want the perimeter, so we add up all these. 3 plus 3 is 6, plus 4 is 10, plus that 0.2, this is 10.2. So if we look at all of our perimeters, we have 11.1, 10.5, 10.2, and 10.5. The greatest perimeter is this skinny one right here, which may or may not have been your first guess. So when we're using distance on the coordinate plane, we see a right triangle here, and we're going to be getting, this isn't in anyone's notes, we're going to be getting 2 points, and we're going to basically make this line segment into a slope triangle, or a right triangle, and we're going to find the length of our hypotenuse here, which is going to be c. So if we flip our page, the first place we're going to be doing that is on page 300. And they don't have a graph for us, so we're going to kind of make up a graph. So it says here, what is the distance between A at -6, -2, and B at 6, 3? So what I would encourage you to do in this space is sort of make yourself like a quadrant, a coordinate plane. if I'm going to put point A at -6, -2, so I'm going to start at my origin. I'm going to go over 6, let's say here. I'm going to go down 2, let's say here. So I'm going to go down 2. So we go 1, 2, 3, 4, 5, 6. And then I'm going to make my B point at 6, 3. So I'm going to go over 6. 1, 2, 3, 4, 5, 6. And then I'm going to go up 3. 1, 2, 3. And I'm just estimating, right? So I have these 2 points. And when I connect them, maybe I should change the color of that. When I connect them, I make what is going to be the hypotenuse of my right triangle. So how do I find out what the leg lengths are? Well, if I know the coordinates, I know what the distance is between them. So if I'm down here at -2 and I'm going up to +3, this distance right here, we're at -2, -1, 0, 1, 2, 3. This distance is 5. That is a leg length. And then I'm going to switch to another color. I'm going to go here from -6 to +6. Well, that's kind of an easy one. I'm going 6 spaces to 0 and then 6 spaces to 6. So this right here is a 12. So now I use my Pythagorean theorem to find the distance of the hypotenuse or your line segment. So a squared, which is 5, plus b squared, which is 12, is equal to c squared. And we're going to go ahead and solve this. If you've started to memorize your Pythagorean triples from earlier in the week, you are doing really great here because you already know what this c is here. But if you haven't, we do 5 squared is 25, 12 squared is 144. We get 169 equals c squared. You take the square root of 169 and you get that your hypotenuse is 13. Some problems on your homework or your assignment is going to look like this. So it says the bank is 5 kilometers south of the library. So here we are at the library. If we're 5 kilometers south, we're going to go down. South is down. 1, 2, 3, 4, 5. And this is our bank. We're going to label it with the word bank. Your school is 3 kilometers west. West is to the left. So I'm going to label this my school. And they want to know, as the crow flies to the nearest 10th, what the distance is from the library to the school. So we're not taking these streets. We're just going straight over like that. So how do we do it? We use Pythagorean theorem. A squared plus b squared equals c squared. So my first leg length is 3. So 3 squared. I'm getting that from right here. 1, 2, 3 kilometers. And then from the bank to the library, we have a 5 kilometer. So I'm going to change colors. From the bank to the library, 1, 2, 3, 4, 5. So 3 squared plus 5 squared. And then it's going to equal my c squared, which is my hypotenuse or the length from the school to the library. So now let's do it. 9 plus 25 equals c squared. 9 plus 25, we're going to get 34 equals c squared. And you guessed it, we take the square root of both sides. And we get approximation here. So we're at about, if we typed this into the calculator, we'd get an irrational number. But we're about 5.8. So we're at 5.8 kilometers from the school to the library. Now let's say you're like, Miss Honor, I do not get this. Well, here's some more examples. I'm going to do one more with you, this example number 1. And then I'm going to say that you should pause it, and I'm going to pause it and work through the next 2. And you can just check your answers if you want, or not if you think you got it. So if you want to use the graph or the space on page 301, we are not doing that problem. So here we go. Find the distance between the 2 points. So here's point 1, here's point 2. I'm going to not only am I going to connect those, I'm going to make them into a right triangle. So this is the distance I'm solving for. This is my right triangle. So my first leg length is 1, 2, 3, 4. My second leg length is 1, 2, 3, 4, 5. I'm going to do something called the Pythagorean Theorem to solve for C. So 4 squared plus 5 squared equals C squared. I'm solving for my distance or my hypotenuse. 16 plus 25 equals C squared. So 16 and 25, I'm going to get 41 equals C squared. We type that into our calculator as the square root of 41, and you are going to get 6.4 equals C. So I rounded to the nearest tenth. You actually got 6.40312423744 and so on, but we're going to round it to the nearest tenth. So I'd encourage you to pause here and try out numbers 2 and 3. I'm just going to show the work. I'm not going to walk you all through it. So pause here and try out 2 and 3. So the second one, if you rounded to the nearest tenth, you got 7.8. And then the third one was kind of cool. It ended up being a Pythagorean triple. This is a 6, 8, 10 triangle. So you ended up getting an even 10. You did not have to round that to the nearest tenth. Okay, so on your assignment that you're about to do on digits, it is distance on the coordinate plane for the first few problems, and then it is review of all of topic 12. So good luck, and remember my office hours are Wednesdays and Thursdays if anyone has any questions. Thanks.